Dear students, welcome to our online classes. I am Ravi Kumar KR, lecturer in Computer Science, gsipucmysuru College, MYSURU. Students, in my previous session, we were discussing about flowcharts, and today we will start the session with one more example on flowchart. Flowchart to find sum and average of given numbers. Flowchart to find sum and average of given numbers. Students, you know what is sum and average? Already we had written algorithm for this. In algorithm, we had written all sum and average of 3 numbers. Now this is, here also the logic, everything is same. First we have to input the numbers, then we have to find the sum. We have to add those numbers, then sum divided by the numbers or terms. How many numbers we have entered. Then we have to print both sum and average. That is the logic of this flowchart. Now let us start writing flowchart for the same. Start here. I am using variable sum to add the sum of the numbers. Next one is to count. I say count. This is, I use this variable as a counter to count for how many numbers. We have to find an average. So this is to initialize the values. Next step is we have to input numbers. Input n. N stands for number. First we have to input the number, then we have to add the number, that is sum equals sum plus n. This is, we have to add the given number here. Here we are entering one number, we are adding that number to sum, variable sum. Next, at the same time, we have to increment this variable count. At the first time it will be 0. After entering one number, we have to increment the value of count by 1. So that should be count equals count plus 1. So this should be in rectangle because it is a processing. Next step, we have to enter one more number. Before this, we have to check for the condition. Suppose if we want to find out the sum and average of 5 numbers, then we have to continue this as long as the count value becomes 5, or we have to keep entering the numbers one by one till the value of the count should be less than or equal to 5. So next one is we have to check for the condition. So what is the condition? It will be count is a variable less than 5. If I say 5 here, I am checking or I am finding out the sum and average of 5 numbers. Suppose if you write here 10 here, so it takes up to 10 numbers, sum and average of 10 numbers. Suppose this condition is true. This rhombus, you take one input and 2 possible outputs here. So suppose this is the input and it produces 2 outputs, that is yes or no. This is, one is yes, it is less than 5, and most another branch is no. This is no. This rhombus takes one input and 2 possible outputs. So here, what is the meaning of this? Count is less than 5. So we have to keep entering the numbers as long as the count value would be less than 5, because we have to find out sum and average of 5 numbers. So here, if it is true means count is less than 5. First time count equal to 0, you are entering one number. After we are entering one number, count value becomes 1. Then it checks for 1 is less than 5, yes. Then we have to enter one more number, or I'm going to connect this one here. It is to accept one more number. It is to accept one more number. Then after this, it comes here. It goes like this. How long it will continue? As long as the value of the count will be less than 5. So once if the condition fails, the value we enter is more than 5 or equal to 5, it will come out of this. Then you have to stop at this stage. So here I am continuing this flowchart at this stage by using connectors. So here after this we have to find average. Average equals sum divided by 5, because I have taken the condition as 5 numbers. Sum divided by 5, it is a processing box. Then we have to print sum and average. We have to print sum and average. Then we have to stop this flow chart. And students, let us start writing this flow lines. See here. Now after this, next step is here I am connecting this flow chart with connector. So here I can write A. I am writing here A. I am connecting this. So this is, we are using the circle for connecting the flowchart written on different parts of a page or different places. So after this step here, I have to connect this branch also. I can use one more connector here. I am using B here. So I am connecting this. Let me explain the flowchart once again. Here first start the flowchart. This is variable sum equal to 0 at the beginning, count equal to 0. I told you already, this is to store the result and this is to count for our condition. And here first input n, we have to enter one number. After this, we have to add that number to this variable here, sum equal to sum plus n. We have to increment the counter here, count equal to count plus 1. Now we have to check for the count. Condition is count less than 5, because we have to find out sum and average of 5 numbers. So this is 5. Suppose if you want to find out the sum and average of 10 numbers, it should be 10. So at the first time when you enter the value first time, its value of count equal to 1, you check for the condition. When 1 is less than 5, it is true, we have to enter one more number. The connection flow lines comes here, so it means that we have to enter one more number, add to this sum, increment the counter, check for the condition. Next time it is 2, count value becomes 2, 2 less than 5, it is true, it come to this line or this statement, it accepts one more number n here. So this will continue as long as the condition is true, means up to 5 numbers. Suppose after 5 numbers, when a value of count becomes 5, 5 less than 5, condition is false. If no, in that case, it goes to this statement. I am using connector here, I am connecting these two statements. So after, if it is no, means we have to find out sum average, sum divided by 5. Why it is 5? 5 numbers. We have to find out sum and average of 5 numbers. 5, print sum and average, stop the flow chart. So this is a flow chart to find sum and average of 5 numbers. Next example is to find the sum of digits of a given number, Next flowchart is to find sum of digits of a given number. So what is the question here, students? See here, suppose n is the given number. Given number is n. For example, I will take 1234. This is a given number n. And students, please note the point here. In this example, we are considering only the whole numbers. I mean, we will not consider any decimal numbers during multiplication and division. So here, now this is whole number. Now what is the question here? Question is sum of digits of a number. So this is the given number n. It has 4 digits. So we have to find the sum of all the 4 digits. Sum must be equals to 1 plus 2 plus 3 plus 4. That is equals to 4 plus 3 7, 2 9 plus 1 10. So your program should give the result as 10. So, and what is the input here? We have to input only one number. Then we have to develop a logic to find the sum of a digit of a number. Now let me explain the logic for this. First, we have to find out the remainder of the division. How do we get the remainder? Given number is n, divided percentage 10. Here, students, please note that this percentage symbol we are using in a program to find the remainder of any division. In this example, n percentage 10 means n is 1, 2, 3, 4. 1, 2, 3, 4 percentage 10 is nothing but the remainder. In this example, remainder is 4. Remainder is 4. Next one is we have to add this remainder to one more variable sum. At the beginning, sum will be 0. So sum equals to sum plus remainder. Sum plus remainder. It is at the beginning 0. Remainder is 4. So sum equals 4. Next step is we have to find the quotient. So at this stage number is 1, 2, 3, 4. So next we have to divide 1, 2, 3, or we have to find the quotient. So that should be our number for division. So here I am going to write quotient. How do you find the quotient here? N divided by 10. N divided by 10. Here example 1, 2, 3, 4 divided by 10. Quotient will be 1, 2, 3. Quotient is 1, 2, 3. It involves these 3 major steps. First we have to find the remainder of the division by dividing the given number by 10, and here we are using percentage operator. It is called a modulus operator in a programming concept. So it gives the answer as 4. So we have to add this remainder to one variable sum first time. Next we want to find the quotient. So given number divided by 10. Here I am using this forward slash, that is division symbol. It stores the quotient of any division, and this is one cycle or one iteration. So next step is what? Next step is we have to take this number. Next step is take n as 123. 123 percentage 10. And again, what is if we divide this? Remainder will be 3. So sum will be s equals to sum is 4. 4 plus 3, this is the remainder, that is equals 7. And here 123 divided by 10, quotient is 12. Quotient is 12. Next, this is second cycle or second iteration. Next step is take this as the number 112 or 12. 12 percentage 10, remainder is 2. Sum will be 7 plus 2, that is equals to 9. And what is the quotient? Now this 12 divided by 10, quotient is 1. Quotient is 1. So this is third cycle. Next one is given number is 1. Now take this as 1, given number 1 divided percentage 10. As 1 is less than 10, you cannot divide. So quotient will be 0, remainder is 1. So it gives the remainder as 1. We adding this to this. S equals to 9 plus 1, that is 10. And here number is 1 divided by 10, quotient is 0. Quotient is 0. So next step is what? Next step is we have to divide 0. That is not possible. So this process here, this is one iteration, second, third and fourth iteration. These many statements are repeated number of times. So this is called iteration or repetition of statements. We are keep doing this process till we get quotient value is 0. Our number should not be less than or equal to 0. This process continues as long as the given number will be greater than 0. That is the logic of this example. Given number is n here 1234. This is one number. The program should be adding individual digit like 1 plus 2 plus 3 plus 4. This is the result 10. So what is the logic of this? Here in the logic, this is first cycle or first loop or first iteration. First find the remainder by using the modulus operator. We get the remainder here. We have to add this remainder to one of the variable s here to store the sum. Next step is our number should be divided by 10 to store the quotient, because next step is how to divide this number. So please observe this. First time 1, 2, 3, 4 is a number. Next time is 1, 2. What is 1, 2, 3? This quotient is 1, 2, 3. Next time is 12. Quotient is 12. It goes on like this as long as our number should be greater than 0. So this is the logic of this flowchart. Now let me write the flowchart for the same. Start, input n, that is a given number. Let s will be the sum, let it be 0 at the beginning. Next, I check for the condition that number is number, given number n is not equal to 0. A is the connector. So input a number, let the sum be 0 at the beginning. We have to check whether the given number is not equal to 0. If this number not equal to 0, we have to follow the following step. True or equals given number percentage 10, sum equals to sum plus remainder, and n number will be n divided by 10. This is processing. This is processing. This branch is no. This is if the condition is false. If condition fails, it is false. If it is no, this is yes, and this is no. So we have to stop the flowchart. After printing the sum, we have to stop the flowchart. So we have to print sum, then we have to stop this flowchart. Next one is to stop the flowchart, and here this line. So see, this is a flowchart to find the sum of digits of a given number. Students, let me explain this once again, how the flowchart works here. See, this is starting point of flowchart. We have to given the number n. We have to accept the value n. After that, let us assume that let variable sum be 0. Then we have to find out whether the given number is is not equal to 0. If it is not equal to 0, we have to follow these steps or processing. R equal to n percentage 10. As I told you, find the remainder, add this remainder to this variable sum, then again n equal to n divided by 10, it stores the quotient. So at this stage your number will be, for example, 1, 2, 3, 4, and at this stage your number becomes 1, 2, 3. So this process goes on as long as your given number is not equals to 0. So after this, next step is check for the condition here. Here 123. 123 is not equal to 0. Do the following steps or follow the statements. It keeps on doing this process here, and once n value becomes 0 or less than or equal to 0, condition fails or false, it will print the sum and it will stop executing the statement. Or here we have stopped the flow chart. So this is a flow chart to find the sum of digits of a given number. Next example is to check whether the given number is prime number or not. Next flow chart to check whether the given number is prime number or not. Students, you know what is a prime number. So what is a prime number? Any number divisible by 1 and the number itself, those numbers are called as prime numbers. Other than those numbers, or if any number which has the factors, then those numbers are not called as prime numbers. So here the program should be, we have to accept one number n. For example, I say 10. The logic is the given number is 10. So from 1 up to the given number n. For example, in this example up to 10. So we have to keep dividing the given number by 1. Next one is 10 by 2, 10 by 3, 10 by 10. This is one method. Here, if in any division, if the remainder is 0, if remainder is 0, then the given number is not a prime number. Students, I repeat once again. So from 1 up to given number, we have to keep dividing the given number. In this example 10. So in any of the division, if we get remainder as 0 or that particular number which has a factor, in that case we have to say the given number is not a prime number. Instead of dividing from 1 to given number 10, it is sufficient if we divide the number from 1 up to the square root of the given number. It is sufficient if we divide the number from 1 up to square root of the given number n. For example, if n equal to 25. So what is square root of 25? Square root of 25 is 5. It is sufficient to divide from 1 to 5. Meaning is that 25 by 1, 25 by 2, 25 by 3, and 25 by 4, and 25 divided by 5. So instead of dividing from 1 to 25, it is sufficient if we divide the number from 1 to square root of the given number. So here there are 5 divisions. In any division, if we get the remainder as 0, then this is the given number is not a prime number. So this is a logic to write a flow chart to check whether the given number is prime number or not. Now let us draw flow chart for the same. Next one is input n. N is the given number, the limit will be square root of the given number n. The limit is for to find out the square root of the given number and to store the value here. So in this example, we have to keep dividing the number from 1 or from 2, because any number divisible by 1 itself. So from 2 onwards up to the limit. In this example, you have to keep dividing the number. So limit equals to square root of given number. It is a connector. Next we are using, this is for loop. We have to keep dividing numbers from for 2 to limit. 2 to limit, we have to keep dividing the number. For 2 to limit, we have to find out the remainder. How do you find the remainder? Given number n, percentage I. Here, if I say 2 to limit, I take I value. This is value of I. From I to limit. I value start from 2. If first time it is 2, next time it is 3, I value becomes 3, 4, 5 like this. So means n divided by 1, n percentage 1, n percentage 2, n percentage 3, n percentage 4. It goes on, keeps dividing the number up to the condition, up to the limit. So here this takes one input, and here there are 2 possible answers for this. One is yes and one is no. If it is yes, if it is yes means remainder is 0. If remainder is 0, this is the given number n is not a prime number. So if it is yes, we have to print. If it is yes, we have to print it is not a prime number. It is not a prime number. Then we have to stop this flowchart. We have to stop this flowchart. This is how we are connecting. Suppose if you look into another branch here, if remainder is not 0, this is no. If remainder is not 0 means we have to again divide by next value of I. First time start with 2, n percentage 2. If remainder is not 0, it come here, it increment the value of I to next number, then it becomes 3. So here n percentage 3, n percentage 4, it goes on like this up to this condition. So once if we met this condition, it will come out of this loop or repetition. If remainder is not 0, it is understood that it is a prime number. So we are printing here it is a prime number. It is a prime number. Then we have to stop this flowchart. So this is a flowchart to find out or to check whether given number is prime number or not. As I told you in the logic, given number n, first we have to find out the limit by finding the square root of the given number. So this is up to here, limit equal to square root of the number. So after connecting this flow line, it is a complete flow chart to check whether given number is prime number or not. Students, next concept is programming constructs. Students, you know what is a computer program. So what is a program? It is nothing but a set of sequential instructions given to a computer. It is nothing but a step-by-step instructions. And these instructions we are writing in a computer language or any of the high-level language. And here what each and every step is nothing but your statements, or we say programming statements. This is statements. nothing but steps in a program. So this is nothing but programming statements when it is written in any of the computer language. So these programming statements are nothing but programming constructs. It is programming constructs. So while writing a program in any of the computer language, first obviously we have to learn that particular language, and each and every language has its own syntax and rules. So we have to follow the rules and regulations or syntax of that particular language, then we can start writing program. So the steps what we write in a program are called as programming statements, and if we follow the syntax of particular language, it is called as programming constructs. There are three basic programming constructs. There are three basic programming constructs. They are, first one is sequential constructs. Sequential programming construct. Second one is selection programming constructs. Next one is iteration statements or iteration constructs. So students, what is programming constructs? Is nothing but programming statements, and these statements we are writing by following the syntax of computer language. They are called as programming constructs, and there are three basic programming constructs in a program. They are, one is sequential construct, selection construct, and iteration constructs. Students, let us discuss all these things in my next session. Thank you very much.